This is GATE 2017 set 2 electrical question number 42. A 120 volt DC motor takes 2 ampere at no load. It takes 7 ampere on full load while running at 1200 rpm. The armature resistance is 0.8 ohm and the shunt field resistance is 240 ohm. The no load speed in rpm is being asked. For NPTEL reference, you can refer to lecture number 30, Characteristics of DC shunt motor, of the NPTEL course Electrical Machines 1 by Professor Devoprasad Kasta, Department of Electrical Engineering, IIT Kharagpur. Coming to the useful data for a self-excited shunt DC motor, you see this is the diagram given where Vt is the input voltage and the motor draws current I, where Ia goes to the armature and If going to the field coil for field excitation. Now the field circuit receives voltage same as the terminal voltage, so Ef equal to Vt. Now Vt is constant, so Ef is constant, and Rf is machine constant, so Ef by Rf is the excitation field current. Now if If is constant, then phi is constant. So for shunt DC motor, phi is constant. Self-excited shunt DC motors, the phi is constant. And Eb proportional to n phi, that is the back EMF developed in the motor. But phi is fixed, so Eb proportional to n. So Eb1 by Eb2 is n1 by n2. Now coming to the solution, case 1, this was the armature circuit with Ra as the resistance and the motor at full load condition. So this is full load condition. It was drawing 7 ampere on full load and running at 1200 rpm. Now with this we have the field circuit also. This is the field circuit, it is Rf. Now Vt applied is 120 volt DC. Now we can find Ia. If is the field current, so field current is Ef divided by Rf. Ef is the voltage across the field circuit, so Ef is equal to the same as Vt, 120 divided by Rf. Rf is 240 ohms, so 0.5 amperes, so 0.5 goes here and remaining 6.5 goes to the armature. Now 6.5 into 0.8, this is the IaRa drop. Now 120 minus IaRa, so you see this is Eb. Simple KVL you apply in this armature circuit. So Eb is 120, which is the terminal voltage, minus Ia, armature current, into the armature resistance. This is the drop. So Eb is found out to be in this first condition. So Eb1, Ia1. So Eb1 is 120 minus 6.5 into 0.8, which is giving 114.8 volts. N1 is already given in the question to be 1200 rpm at rated condition, that is full load condition. Now in no load condition, Ia2 is given as I2 minus If. If is same, which is 0.5 amperes, so I2 is 2 minus 0.5 equal to 1.5 amperes, the armature current at no load condition. So Eb2 is coming out to be 120, which is Vt, minus Ia, which is 1.5 into Ra, which is 0.8. This is 118.8 volts. So Eb1 by Eb2 is equal to n1 by n2, as phi is constant, so it only depends on the rotational speed. Now n2 equal to Eb2 by Eb1 into n1. N2 is 118.8 divided by 114.8 into n1, which is 1200. So N2 is coming out to be 1241.81 rpm. So at no load the speed slightly increases to 1241.81 rpm. So the answer is 1241.81 rpm. Thank you.